Greetings to one and all present here. My name is Naman Sharma and I am currently a fourth year BTech student in the Department of Civil Engineering at Faculty of Engineering and Technology, Lucknow University. So today I am going to present a seminar on the topic of membrane bioreactor technology. So as we can see in the table of contents, we have here various sections like introduction and working mechanism of the membrane bioreactor technology, the reuse potential for the effluent, and the pros and cons of the membrane bioreactor technology. Then we have some case studies, and finally we have the conclusion itself. For now, we will move on to the part of introduction. So as we can see here, MBR or membrane bioreactor technology is a wastewater treatment method based on the biological treatment followed by the membrane separation itself. So it mainly comprises of an intense activated sludge process with biomass separation stage being carried out by the membrane cassette which are located in the bioreactor itself. It also uses processes of microfiltration and ultrafiltration. Finally, the biomass is separated from the treated water using the membranes and it provides us with the final effluent. Now, we will move on to the working mechanism of the membrane layer itself. So to understand the working of the membrane cassette, we have to understand the working of the membrane. So the membrane is an intervening phase, separating the two phases, acting as a active or passive barrier to the transfer of material between the two phases. These membrane fibers have billions of microscopic pores on the surface, and these pores act as a barrier to the impurities, which allows the clean water to pass through these membrane surface, and then the clean water is drawn through the pores using gentle suction. Now we have understood the working of the membrane layer. We will move on to the working mechanism of the MBR plant itself. As we can see here, raw sewage from the holding tank is passed through fine screen to remove the substance or particulate matter that could damage the membrane in the membrane cassette, as the membrane is very prone to damage. So the membrane molecules immersed in the aerobic tank are biologically degraded by activated sludge, and the main thing to note is that the mixed liquor suspended solid concentration in the MBR plant should be from 10 to 12 gram per liter. These membrane pores not only remove the suspended solid but they also remove bacteria as well, and they separate solid from liquids during the filtration process as well. Also, flocculant or coagulant dosing can be used for phosphorus removal as well, and a large number of bacteria and pathogens are also removed from the water in this process, as we can see from the diagram here. Now we come to the point of reuse potential for MBR effluent. So the MBR effluent quality is completely acceptable for reuse purposes, and the reclaimed water can be used directly for municipal watering, toilet flushing, car washing, and many other various processes as well. This water can also be used for the process of cooling down machines. Therefore, a lots of urban water can be used and a large amount of water can be saved, thus moving towards a sustainable future as well. Now we come to the advantages of membrane bioreactor technology. So it provides a higher quality effluent as compared to the various other treatment plants, has a higher nitrogen removal rate than any other process, has a comparatively low sludge yield which reduces the cost of sludge handling also, and it is easy to operate and maintain, also reduces the plant budget, and has a compact size as compared to the various other water treatment plants. Now we come to the drawbacks of membrane bioreactor plant. So due to the presence of membrane in the membrane cassette, this plant has an increased capital as well as maintenance cost, and due to its high cost it's not in much use as well, and also for its regular operation it has a very high energy demand, and the membrane may be sensitive to some chemicals as well, and it can be blocked by particulate matter or solids, so it needs frequent membrane monitoring and maintenance as well. Moving on to case study number 1. As of now, almost 200 membrane bioreactor plants are currently in operation for various wastewater treatment facility, and 90% of them are employed in municipal treatment. In the application of MBR, which is based on polymeric materials, the leading country is Japan, where most MBR systems are used for the water recycling in the buildings itself. In India, The MBR systems are now used for the treatment of domestic wastewater from households, industries, commercial establishments, etc. So in Delhi, right now there is a full-fledged 4.54 million liters per day sewage treatment plant which is based on the membrane bioreactor technology and is right now located in the Commonwealth Games village near Akshardham temple. So this plant was built by an organization known as Toshiba Water Solutions Private Limited on the request of Delhi Jal Board, and it started its operation in the year 2011 itself. Right now it's located in the Commonwealth Games village Akshardham, New Delhi, and it has a filtration capacity of 4.54 million liters per day. We will discuss some of the key features of the plant. So the treated water is reused for the toilet flushing in the flats of the Akshardham complex located nearby and also in its AC chillers. And some acoustic enclosures are also provided around doors, which help in reducing the noise level by about 5 to 10 decibels as well. And the control system for the plant has been designed so as to be operated automatically, which is beneficial to the department from an energy saving point of view as well. Also, the entire plant is located in a single building as it is very compact in size as well. We are going to take a look at the second case study. As we know, China features many of the largest municipal wastewater MBRs in the world, and one such MBR is installed at the Kunming city, which started in the year 2012. At an average daily flow of almost 1,50,000 meter cube per day and a peak loading factor of 1.3, we can say that it is a substantial plant, and it is also constructed below ground in compliance with the urban planning of the city, and it provides a non-potable reuse water flow of 45,000 meter cubes per day. As we saw in the previous slide, the plant has a very large amount of filtration capacity. So this plant is intended to meet the urban sewage pollutant discharge standards of 10 mg per liter for BOD, 10 mg per liter for suspended solids, 15 mg per liter for total nitrogen, and 0.5 mg per liter for total phosphorus, as well as the use of a membrane bioreactor for treating the main flow. The sludge is dewatered by centrifugation and the ventilated air is treated by biofiltration as well. So now we have come to the conclusion that MBR or membrane bioreactor technology presents an attractive alternative to the conventional activated sludge process of the treatment of wastewater, as it is a more robust technology with smaller footprint and it also produces a higher quality effluent. It can also meet the increasing requirement of the treatment of the discharge nowadays. So I have also provided some of the list of the references which were helpful for me in the preparation of this seminar. Thank you for your valuable time.